Okay, over the last few class periods, you guys have had a lot of questions over equations with fractions. So I kind of wanted to address that in a short little video. Um, I find that you are having trouble with, let's say, 3/5 x is equal to 5. When you've got a fraction and it is a multiplier, you're getting confused on what to do. So if you'll go back and use those steps like I talked to you about before, anytime you have fractions in an equation, if you will multiply by the denominator, so in this case I'm going to multiply by 5 because that's the denominator, then that's going to help you out because now these 5s are going to cancel, and so on the left-hand side of the equation, I'm going to have 3x, and on the right-hand side, I'm going to have 25. And so now to finish the equation off, I would divide by 3, and so x would be equal to 25 over 3. This technique works no matter what the equation looks like. You know, I noticed in some of your work you were having equations like x plus 1/3 is equal to 5/7. And you guys were struggling with that. You can use the same exact technique. In this case, you would have to find the common denominator, and the common denominator between 3 and 7 is 21. So you would multiply each of these by 21. Now, in doing that, multiplying by 21, then in my first multiplication right here, I'll just get 21x. But here, 3 goes into 21 7 times. So that's going to give me 7 times 1, which is 7, equals 7 goes into 21 3 times, and so that will be 5 times 3, which is 15. And so now you can solve that equation just like a simple two-step equation. You would subtract 7, and so you get 21x is equal to 15 minus 7, which is 8. Then you would divide by 21, and so your final answer would be x is equal to 8 over 21. And you would simplify if possible. So it doesn't matter whether your fraction is on the right side or on the left side, if it's the coefficient, none of that matters. Okay, you find the common denominator, and like in this first one up here, right here, there was only one denominator, 5. Now in the bottom one, we had 2 denominators, so we had to come up with our common denominator, which was 21. But the technique still works the same either way. Okay, I hope this helps.